This span goes out here to about where those light towers and items over there are sitting and that scaffolding coming up. At that point, you'll have a tooth joint in the bridge. So if anybody's familiar with some of the old joints we used to have on the bridge, this is in fact a jointless bridge in that those tooth joints are only over 2 piers on this bridge, and they're specially designed to actually route water around the steel. I'll show you that when we go down bottom. But needless to say, that's a design we do at the Virginia Department of Transportation to actually prevent degradation of the steel. So no longer will the steel under the bridge be suffering from water intrusion and rust, and it'll help with maintenance in the long term on this project. We're going to talk a lot more about that as we go down bottom. For those who didn't know, we did do this project in accelerated fashion. This project was originally considered for a 30-month phased delivery. We came in and said we can do it cheaper, better, faster, and with more quality if we do it in 16 months. And we want to thank our partners at the City of Fredericksburg and in Main Street and in Stafford for supporting us and doing that. Took a lot of work meeting with you guys and having faith in us to get this done. And we're here to tell you that this is going to be delivered in October on time with the maximum incentive to the contractor. So we're doing everything we can right now to make that happen. So right now we are actually working with some folks over at the city and with Stafford to plan an opening event out here. We're very much looking forward to that. One of the things I like to point out is some people come down here and they ask, why are the beams rusted? Why are we putting up rusty steel from the get-go? Anybody have any thoughts on that before I answer? There you go. So what we have is we have weathering steel down here. This steel is actually designed to rust and get a weathering patina on it so that we don't have to come down here and coat and paint and do all that over the life cycle of this bridge. That steel, once it gets that rusted patina on it, will actually last a lot longer and keep the corrosion off of it. Couple other features you see down under here. You see our abutments up under here where we actually have the beams. I had a couple people asking me, well, it feels like the bridge is moving a little bit underneath of me. And while we don't have any traffic loading on that bridge right now, that bridge with this wind coming under it, you're gonna feel a little bit of movement in that bridge because these bridges, when you have these, they ride on some elastomeric or basically rubberized pads that allows a bridge to move and flex, because what you wouldn't realize is as this sun heats up this steel, that steel can lengthen across this entire span as much as 2 to 3 inches. And so we have to compensate for that when we do these designs. Another little feature that a lot of people ask, why do we hop, skip, and jump around the bridge as we're pouring the slab? Why don't we work our way all the way from one end to the other? Well, what we have when these beams come in, they have what's called camber on them. What that means is that we actually have to load the bridge in the correct sequence to get those beams to come down to a flat or nearly flat grade for drainage. So we actually sequence the pour placements to make sure that you get drainage on that deck in the end, because we don't have the luxury of having a paving machine or something like that go across the end where we can actually set the grades. Believe it or not, these foundations, as old as they are, have very little degradation underneath of them. They're in pretty good shape. There's only 1 or 2 spots where we had to put in some mitigations to prevent that scour. But these substructures should last as long as the new superstructure we're putting over top of it. And you can even see some evidence of where we've done repairs on this pier down here. You actually have, this is the one that's underneath that tooth joint I kept talking about. And so at this particular pier, we actually build this Virginia abutment or Virginia pier cap here, where you have that trough coming off that actually is going to take the water from that tooth joint and redirect it away from that steel and dump it out here. We'll actually be putting some, for those worried about, well, is that going to create a big hole in the ground out here? Those with the folks at the city who are worried about maintenance. Actually, what we're going to do is have some riprap and stuff down under there to armor it, so all of that will be protected. But you can actually see here where we've done substructure repairs on this pier. You can actually see some of the original steel from the construction here, and the seats are still open. So there were actually points where we started doing this work, and you could actually see holes that we were punching through here as we were doing demo. The good news is most of the load comes down through these columns, and we have strict specifications about how much they can demo at any one time to make sure that it stays structurally competent. And then we've gone back in and put new concrete in that's modern mixed concrete. It's going to last a lot longer. And then on top of that, in the end, this is actually getting a very special corrosion protection system sprayed on top of it that'll actually protect the rebar and the reinforcing in it from future degradation and corrosion. So basically, we're ensuring that these piers, even though we were punching holes through them doing this demo, are going to, again, last the life cycle of this bridge overhead.
How many types of concrete?
I think we have about 5 approved mixes on this, and then a couple of specialized mixes for like these corrosion repairs down here.